3, and we're going to be talking about solving equations and absolute value equations. So at the top of the page, I have a little refresher from what Mrs. Punzel talked about earlier and also algebra. So inverse operations is what we use to solve. Our goal to solve is to isolate the variable, like we talked about in lesson 1.1.4. Okay, we have to get the x, usually x by itself. To do that, we need to use inverse operations. So remember, those are operations that undo or cancel each other out. So you'll notice at the top of the page here, I have all of the inverse operations listed. Adding and subtracting cancel each other out, multiplying and dividing cancel each other out, and the one that you learned back in algebra, which you might not have used last year, is squares, the little exponents of 2, and square roots. They cancel each other out, okay? So go ahead and try. I'm going to do a couple of these because I don't think we need all of these for help, but I'm going to try a couple. So the first one I want you to try on your own because that's exactly what Mrs. Punzel talked about in 1.1.4. Number 2, I'm going to go ahead and just show you what I would do when I'm solving this. There are several different ways you can do this, like Mrs. Punzel said. But the first thing I would do is get rid of that plus 9. We have to do the inverse operation. So I am going to go ahead and subtract 9 from both sides. Because remember, what you do to one side, you have to do to the other. That's going to cancel the 9's on the left because one's a positive and one's a negative. And what I'll be left with is 3/7 x equals 15 minus 9 is 6. Now, when you have that, we have a fraction. Oh no, fraction. Don't worry, don't freak out. Fractions are okay. Fractions are our friends. You just have to know how to manipulate them and work with them. So what I would go ahead and do is to cancel that out, I would multiply by the reciprocal. Remember, reciprocal is just a fancy word for flip-flop. So I would go ahead and multiply both sides by 7/3. By doing that, what ends up happening is the 7 that I multiply and divide with cancel out. Same thing with the 3's. They cancel out. So I'm left with just x, and that is equal to, now I have to just remember how to multiply fractions. Good news is you don't have to do a lot. You just put that 6 over 1, because that's any whole number, and then multiply straight across. So this becomes 42 over 3. And if you need to, get your calculator, but otherwise 42 divided by 3 turns out to be 14. So that's one way to work with fractions, okay? If we take a look at the next example that I'm going to do, which is 1/3 x plus 1/4 equals x minus 1/6, I'm going to do this one because there are so many fractions. Let's just get rid of them right away. So I'm going to treat it the exact same way Mrs. Punzel did in 1.1.4. I'm going to go ahead and multiply everything by the common denominator, basically, but a multiple that can be divided evenly by all 3 of those numbers. So if you think about 3 can be multiples of 3, 6. That's awesome because 6 can be divided by 6, but 4 can't go into 6. You have 9, that doesn't work, and then 12. So I'm going to multiply everything by 12 in this parentheses, in the whole equation. But to do that, just like we just reviewed multiplying fractions, I'm going to put it over 1. So when I go ahead and distribute this 12 over 1 to all 4 parts of that original equation, just multiply straight across. Numerator times numerator, denominator times denominator. So this becomes 12 over 3x plus 12 over 4 equals, x is in a fraction, so I'm just going to multiply that times 12. And then 1 times 12 is 12, and 6 times 1 for the denominator is 6. Now I can go ahead and simplify. 12 divided by 3 is 4x plus 3 equals 12x minus 2. Okay? And then from there, you should be able to continue and solve that. But remember, we have to get our like terms on the same side. So I would go ahead and subtract 4x from both sides. Since it's a positive, I'm going to subtract. I get only 3, and it's a positive 3, so if you want to put that plus there, absolutely. If it's a negative, you have to, but for plus, you don't have to. 12x minus 4x is 8x minus 2. Since I have my x's over here on the right side, I need to get rid of this minus 2. So to get rid of that minus 2, I'm going to add 2 to both sides, and that becomes 8x on the right and 5 on the left. Last thing, x is with times 8. So to cancel that out, I would divide both sides by 8, and I would be left with x is equal to 5 can't be divided by 8, so leave it as a fraction. Just leave it as 5/8. I can't simplify it any, and that would be my final answer. Okay. The one that I skipped up here, very similar. Just make sure you use the distributive property. And when you use the distributive property, just make sure you watch your signs. So when you distribute the 4, that would be 12x minus 20 equals, now when I distribute this negative 2, I only distribute it to what's inside the parentheses, not the minus 6x. But negative 2 times a negative x ends up being a positive 2x. And a negative 2 times that plus 8 ends up being a negative 16. And then you can go ahead, and since the 2x and negative 6x are on the same side of the equal sign, you just combine them. You don't do the opposite or anything fancy like that. You just combine the like terms. So those become negative 4x minus 16, and then 12x minus 20 on the other side. And then it's the exact same thing that I just did with the next example. Okay, taking a look at the story problem, everybody's favorite. We love story problems. So it says a real estate broker's base salary is $25,000. She must earn a commission of 7% on total sales. How much must she sell in order to earn $70,000 for the year? So the thing that we're trying to find here is how much money she needs to make for sales. That's what we're trying to find. Does she have to sell $100 worth of stuff to make $70,000? Does she have to sell $5 million to earn $70,000 for the year? We just need to know that. So there are two pieces that her salary is broken down into. She has this original base salary. She gets no matter what. She gets whether she sells everything or nothing. So she has that, which is $25,000, doesn't depend on anything. And then she has this other 7% of the total sales. So she has to take whatever she sells, and that's what we don't know, times 7%, and add that to her base salary. So to represent that, can't work with percents, so we got to make that as 0.07, a decimal. Remember, move the decimal 2 spots to the left. And then x, because that is our unknown. That's what we're trying to find. Right? Once we have that, then we can set that equal to, she wants to make the $70,000 for the year. And what I want you to do is go ahead, pause the video, and then try to come up with all of those answers. Okay, finish solving. Okay, so if you solved this correctly once you've unpaused the video, you should get for this last one that she would need to sell, this is her sales, approximately $642,000, $857.14 in order to make that $70,000 a year. It's a lot of sales. I hope she's selling big ticket items. Okay, if you go up to the one before that, after you solve it, you should get x is equal to 1/4. If you don't get that, try to look at the filled in notes. Otherwise, bring that to class and I'll be happy to go over. Any of us will be happy to go over it. The first one, you should have gotten x is equal to 10. And the last one, that's kind of, the GC means graphing calculator. You can absolutely use that to solve it, but it's actually a lot easier not to. So go ahead, give that a shot. That's kind of like an advanced question because we haven't done it for so long, but I'm going to give you a hint. This x squared has to be isolated. Get it by itself. Pretend it's an x. Get everything, do everything you did for the previous examples. And then when it's all said and done, you're going to have x squared equals 25. Again, you have to fill in those blanks. What cancels out this exponent of 2? Hopefully you remember from either last year algebra or my notes at the beginning. The square root does. The square and square root cancel each other out. And then we end up getting x is equal to, a lot of people just want to write 5 because square root of 25 is 5. But remember, with quadratic equations, most of the time you get 2 answers. So it turns out to be plus or minus 5. It's a positive or a negative 5. So you do have to include both of those. Okay, that's kind of a review, recap, a little bit more challenging equations. Now we're going to go into more of a recap, but this has been a long time. You didn't look at this at all in geometry last year, but we are going to talk back, and we did learn about this in algebra. Absolute value equations. Very similar to what we just did. However, you get 2 for the price of 1. Anytime you are solving an absolute value equation, remember it represents the distance from 0 on the number line. So you can either go to the right or to the left. That's what you can do on the number line. So you end up getting 2 solutions for absolute value equations also, most of the time, not always. But what you have to do is, an example here, is if you have the square, or the absolute value of 5 is equal, absolute value of x is equal to 5, you get 2 solutions. You get either, it can be 5, x can be 5, because the absolute value of 5 is equal to 5, or the absolute value of negative 5 is equal to 5, because both negative 5 and 5 are 5 units away from 0. So that's what we're going to have to do. So what we need to do is we need to get our equation, and this is the big idea here, we need to get our equation to look like this. We need to isolate the absolute value bars. Once we do that, then we are going to set up 2 equations. We're going to set up what's inside the absolute value is equal to the positive version, and what's inside the absolute value bar is equal to the negative version. That's the only thing that changes. Okay? So if we take a look at this first example, the absolute value bars are isolated. They're all by themselves. So I'm just going to go ahead right away and set up 2 possible solutions. Either what's inside the absolute value bar, so just 2x minus 5, is equal to 9, or what's inside the absolute value bar is equal to the negative, or the opposite of that. Now you have 2 separate equations that you can go ahead and solve very quickly just by adding 5 to both sides. So you get 2x is equal to 14. Divide both sides by 2. So we get x is equal to 7. Or do the same thing over here to the second equation. This is why I said you get 2 for the price of 1. Divide both sides by 2, and you end up with x is equal to negative 2. These are your 2 solutions. X can either be 7 or it can be negative 2. Either of those values will make the original equation true. Okay? Now, for the second one, very similar. The only difference, though, is that we do not have the absolute value bar isolated. So before you can do anything else, you've got to get rid of that minus 6. So what's the inverse operation? Move it to the other side. I'm going to add 6 to both sides. That will leave me with the absolute value of x plus 8, absolute value of 8x plus 1 is equal to 17 plus 6 is 23. Okay. Now, since I have the absolute value bar isolated, now I'm going to go ahead and set up my 2 solutions, either the positive or the negative. So, and I like the arms there, so I can see that I'm doing both, but you don't have to write them if you don't want to. So I'm going to set up 8x plus 1 is equal to 23, or 8x plus 1 is equal to negative 23. Okay. Pause the video, go ahead, try finishing that off, and then I'll give you the answers when you're done. Okay, once you do the work, you should get the 2 solutions are x is equal to 11 fourths, or x is equal to negative 3. So those are your 2 solutions that will make that original equation true. Okay. If we take a look at the one underneath that, this one's going to trick you. I know you want it, absolute value bar is isolated, right? It's isolated, so let's set up our 2 arms. We got the 2 options, negative 11 and 11. However, red flag, we have a negative 11. When can the absolute value of something ever be equal to a negative value? If I have 11, the absolute value of 11 is 11. If I have negative 11, the absolute value of negative 11 is still 11. So for that reason, there is no solution here. There's no answer that I can put in for x that will make this equation true. So you can either put the 0 with the line through it, or you can write no solution, however you want to do that. But that's basically what it's saying. Impossible, can't do it. We go to the next one. It looks really funky, okay? But just read what it's saying. It's just function notation, so don't be scared. It says the exact same thing we've been doing since probably 3rd grade. But this says f of -8. So remember, this is saying x is -8. And we also want to evaluate f of 0. This is saying, I don't even know where to go. Let's just read through it. It says f of x is equal to, and there are 2 parts. You have this first part, which is on the first line, and then you have the second part, which is on the second line. And what's at the end of those is what's going to determine what I'm going to use. This says when x is less than 0. What values are less than 0? -1, -2, -3, -4, -5, -8. So when I am trying to figure this out, I'm going to use that top one. The second one says when x values are greater than or equal to 0. Well, is 0 greater than or equal to 0? Absolutely. So I'm going to use that second one. So I'm going to plug 2 different numbers in, and I'm going to plug them in, one to the top and one to the bottom. And I determine that based on what's at the end here. So pay attention to those intervals, the inequalities that tell you those values. So for f of -8, that's going to be, like I said, the very top equation, because that's x is less than 0 and -8 is. It's going to be 4 times the absolute value of 1/4 times -8 minus 5. And then because it's all numbers and it's evaluate, I just have to use order of operations. Absolute value is a grouping symbol. So you have to do that first. So everything that's inside I have to do first, get it to one number, and then I can take the absolute value. So this is going to be 4 times 1/4 times -8, ends up being -2. And then I'm going to take away 5. When I have -2 minus 5, this becomes 4 times the absolute value of -7. Now, since the absolute value is down to one number, I can find it. Absolute value of -7 is 7. So this becomes 4 times 7, which is 28. So I'm going to say that f of -8 is equal to 28. And that's how I would write my answer. When x is -8, y is 28, and that would be an ordered pair on the graph, but that would be my solution for this problem. Okay. For the other one then, now it's going to be f of 0. This one, I have to use the bottom equation because x is greater than or equal to 0. So I'm going to plug 0 in to 3 times 0 minus 4 and simplify. All order of operations, so 3 times 0 turns out to be 0 minus 4. This is the absolute value of -4, which is 4. So f of 0 turns out to be 4. And that again would be the ordered pair 0, 4 on a graph. Okay, last one. This one's again a little tricky. It's your advanced level type question. Graphing calculator, you can do it on there, but again, this is something that I wouldn't recommend. It's still solving. It does have absolute value bars in it, but you will notice that both absolute value bars are the exact same. So treat it like it's just a variable. So get them to the same side. You can combine them. They're like terms. They like each other. So what you're going to do is add the absolute value of x minus 3 to both sides. Add the absolute value of x minus 3 to both sides. And what ends up happening, if I have 2 of something and I add 1 of something, I've got 3. So this would be 3 of that something, and the something turns out to be x, the absolute value of x minus 3. Okay. Now you just have to worry about isolating the absolute value bar. And let me just give you a little hint here. What cancels out that 3 in front? That's multiplication, remember. That's the exact same thing as 3 times. Don't distribute it into absolute value. It can only be distributed into parentheses. So you're going to divide both sides by 3. And you're going to end up with the absolute value of x minus 3 is equal to 4/3. And then you can go ahead and isolate or set up your two arms, your two solutions. Okay? Let us know if you have any questions, and we'll be happy to answer those in class. Good luck.